Hey everybody, Mr. Reeves with you. And today we are continuing our work through the IXL skills on proportional relationships. In the previous video, I went through skills 1 through 4. Today we are going to pick up on skill number 5, which is writing equations for proportional relationships from graphs. All right, so just a reminder, a proportional relationship is a relationship between two quantities where one is the product with a constant of the other, and we call that K is called the constant of proportionality. Constant, let me try that again. The constant of proportionality. Proportion. Don't you love how the words are so short? Constant of proportionality. So the first number is x. We multiply that by k and it gives us y. Y equals kx, or we say y divided by x is equal to k. Again, k is called the constant of proportionality. All right, so when we have a graph, the way to recognize a proportional relationship on a graph is you're going to have a straight line that goes through 0, 0. And if you pick any point on the graph and divide the y by the x, you'll get the same thing. So for example, on this graph right here, if we take this point right here, that point is 1, 5. And if we take this point right here, that point is 2, 10, right? And if we do 10 divided by 2, we get 5. And if we do 5 divided by 1, we get 5. So that means that k is equal to 5. All right, and as we said, y is equal to kx. That's our equation. So y is equal to 5x. So every value on this graph, the y value is 5 times the x value. So if I were at a half, it would be at 2.5, right? If I were at 3, it would be 15, which is off the graph, and so on. So, all right, so our equation that we're looking for this one would be y is equal to 5x. Excuse me. Okay. All right, so if we take a look at this relationship between gems and mines in this game that Cora and her friends are playing, first of all, we know it's a proportional relationship because it's a straight line that goes through 0, 0. So let's find a point on this graph. Looks like 1, 5 is a point on this graph. And 2, 10, wow, they're not very original, are they? It's the same exact relationship. And what do we get again? Y is equal to 5x. All right, let's skip up to the next level. Maybe they'll get a little bit more interesting here. All right, so again, it's a proportional relationship, a straight line going through 0, 0. If we find a point on this line right here, what do we have? Let's see here. That is 1 and 35. By the way, you can use any point you want to. I could pick any point on here. The problem is up until that point, it was not on the grid, right? We're looking for a point that's on the line and on the grid. All right, so we do 35 divided by 1. I'll give you some think time on that. Wow, you guys are amazing. 35. So our equation is going to be y is equal to 35x, right? Okay, I don't think they can really make this too much more difficult. All right, so we've got this one. Again, it's a proportional relationship between the number of feet and the number of times that Allie turns the crank. Now, if you look through here, it's at a perfect 45-degree angle, right? 2, 2, 4, 4, 6, 6, 8, 8. That tells me that I have a slope of 1. My constant of proportionality is 1 because the x's and y's are the same. So yes, it is a proportional relationship, and it's either y equals 1x, or you can simply just put y equals x. It's kind of a little better just to put y equals x. All right. What about this one here? Oh my goodness, this line does not go through 0, 0. It does not go through 0, 0. That means if I pick points on this graph, all right, for example, this one right here, 2, 8, right? If I do 8 divided by 2, what do I get? I get 4, right? But if I do this one right here, this point is 612. All right, if I do 12 divided by 6, I get 2. Do you see how they are not the same? All right, so y divided by x did not equal y divided by x, so this relationship is not proportional. All right, so again, you could tell just by looking at the graph since it doesn't go through 0, 0, but I want to explain why it's not proportional. Okay, so if a relationship is proportional on a graph, it must be a straight line and it must go through 0, 0. All right, what do they have for us in the challenge zone? Let's see what we got. All right, lemonade with lemons from her mother's tree. All right, do we have a proportional relationship? Again, straight line through 0, 0. If you don't believe me, let's take a look at that point right there. That point is 20 and 100, right? All right, that point right there sure looks like 10 and 50, doesn't it? We don't know for sure, but we do know it's a straight line through 0, 0. So we're going to say yes. All right, and it was 100 divided by 20, which is 5, right? So that means that there are 5 lemons for every pitcher of lemonade. 5 lemons for every pitcher of lemonade. All right, that's all we're going to do on this skill. Let's skip over now to skill I6. All right, select the graphs that show a proportional relationship. All right, so if it is going to be, go away blue stuff. If it's going to be a proportional relationship on a graph, it must meet 2 conditions. It must be a straight line. Now in math, all lines are straight, all right, but many times students don't think of lines as having to be straight, maybe because they've stood in some lines at like Disneyland that go all around and we call them lines, but it must be a straight line and it must pass through the origin. It must pass through 0, 0. If it meets those 2 conditions, then it will be proportional, okay? If it meets one of the 2, it is not proportional. Obviously, if it meets neither of them, it is not proportional. So select a graph that shows proportional relationship. Does that a straight line that goes through 0, 0? Yes. Is that a straight line that goes through 0, 0? So it is yes. Okay, these are both straight lines, right? But this one does not go through 0, 0, so I'm not going to select that one. I'm going to select this one. So straight line, but not through the origin. Straight line and passes through the origin. Okay, ooh, now they've got an equation. Okay, so if an equation is going to be proportional, as we have discussed before, it must be in the form y equals kx. Y equals kx. And let me show you real quick why. If I do y equals 5x, if I do x is 1, y is 5, right? If I do x is 2, y is 10. If I do x is 3, y is 15, and so on. Any of these ones, if I do 5 divided by 1, I get 5. 10 divided by 2, I get 5. 15 divided by 3 equals 5. But if I do this one right here, if I do 1, I get 7, right? If I do 2, 2 times 6 is 12, plus 1 is 13. If I do 3, I get what? 19? And if I do 7 divided by 1 and 13 divided by 2, and I do 19 divided by 3, then the answer is going to be no. They are not the same. They are not the same. So a proportional relationship from an equation must be y equals kx and nothing added or subtracted afterwards. So these two are going to be yes, right? Because there is nothing added or subtracted. All right, take a look at this one. Straight line through 0, 0. Good. This is a curve. It passes through 0, 0, but it is a curve, so this one is no. Remember, it must be a straight line and pass through 0, 0. If it meets one of those 2 conditions, in this case it goes through 0, 0, but it's not a straight line. It is no. All right. Wow, we skipped all the way to the challenge zone. Okay, are these both multiples of a constant? Yes, this constant is a fraction, and that constant is a fraction, but fractions are constants. Okay, we can do it. Okay, really, this is a challenge? This is the exact same thing, huh? Yes and no, because it does not go through 0, 0. I think we have exhausted this skill. Let's go on to the next one. Identify proportional relationships from tables. All right, so as we have said before, if it is a proportional relationship, k is equal to, k is equal to y divided by x. That is a constant, and it must work always, okay? Always a constant. Any exception will make it not a proportional relationship, okay? So if you take a look at this first one, what do I have? I have 5 over 3. 10 over 6, what's going to happen to 10 over 6? It's going to simplify to 5 over 3. What about 20 over 12? If you divide 20 by 2, you get 10. If you divide 12 by 2, you get 6, and you have 10 over 6. Divide those by 2, you get 5 over 3. So that one is a yes. What about this one? 3 over 4, 6 over 8, 9 over 12. They all simplify to 3 over 4. So they are both proportional relationships. All right, take a look at this one right here. This first one, 4 divided by 1 is 4. 10 divided by 3 is not 4, is it? 16 divided by 5 is not 4. So this one right here is a big no. This one right here, 3 divided by 2, 6 divided by 4, 12 divided by 8. They all simplify to 1.5, right? So the constant of proportionality for this one is 1.5. The equation would be y equals 1.5x. That one is a big yes. All right, let's skip up to a more difficult type of problem, maybe all the way in the challenge zone. Oh, fractions. Here we go. So this first one is 8/3 divided by 2. Well, that's going to be 8/3 times 1/2, right? Which is going to be 8/6, which is going to simplify to 4/3. So our first one was 4/3. If we do if we do 20/3 divided by 5, that's going to be the same as times 5 over 1, right? And that one's going to give me 100 over 3. All right, not working at all, is it? And of course, 8 divided by 6, well, that one simplifies to 4/3. Whoops, you know what? I apologize. The second one is not supposed to be times 5. It's divided by 5, which is times 1/5. I take that back. The fact that the third one worked made me go back and look at my second one. Yes, I made a mistake. There we go. This one is yes. I apologize. But hey, Alec, I caught my mistake, and it only wasted like 1 minute of your life. All right, this one right here, 1/5 divided by 1 is going to be 1/5. 8/5 divided by 8, that's going to be 1/5. And 3 divided by 15, that is also 1/5. So the constant of proportionality here is 1/5. The equation would be y equals 1/5 x. All right? Okay, it does not get any harder. We're already in the challenge zone. Simply do y divided by x and see if you get the same thing every time. Doesn't matter if you're working with fractions, decimals, all right, mixed numbers, doesn't matter. You simply have to see, does y divided by x equal a constant? And if it does, it is a proportional relationship. Oh my goodness, we are zooming through these. We're on our last one for this video. Skill I8, graph proportional relationships and find the slope. All right, you know what? We haven't learned how to find slope yet, so I'm going to actually save slope for a whole separate video. Sorry guys, I promised you 4 skills. We only did 3. I didn't realize this last one had slope, and that's a whole different concept that we'll get into next time. Have a great day, everybody. Bye.